A plane is flying 350 miles per hour, bearing north 40 degrees east. A wind blows from south 20 degrees east at 40 miles per hour. Find the new speed and bearing of the plane. The first thing we have to do is draw a picture. And so we have a north axis, and we're going to draw a plane that's going 350 miles per hour, and north 40 east means that it's going to be that way. Okay, so there's our plane, 350 miles per hour. Now, we always want to attach our vectors head to tail if we can. And so when I look at this, I come here and I say, okay, I'm going to draw a line, a north-south line. And I look at this and it says a wind blows from south 20 degrees east. So I'm going to start at south and I'm going to go 20 degrees towards the east. Okay, 20 degrees towards the east. And that's my wind. And the trick here is it says it is from south 20 east. So if you have a wind that is south 20 east and it's from that direction, it's going to be blowing this way. If it says it is towards south 20 east, it will be blowing this way. So from south 20 east means it's coming from the southeast. Towards south 20 east means it's going to the southeast. So the head of this vector is going to be here. Oops, I've connected my vectors head to head. And I don't really like to do that. So I'm going to take this picture and redraw it. The plane hasn't changed. It's still going to be north 350. And it's still going to be 40 degrees. But this time, instead of drawing my vector here and being connected at the head, I'm going to draw my vector here. And it's 40 miles per hour. And if this angle here was 20 degrees, this angle here will also be 20 degrees. So now I have my airplane and I have my wind. The resultant will be from the tail of the airplane to the head of the wind, R. That's my resultant. So now I have a triangle, and with this triangle I have to be able to find enough information to solve this problem. So here's the trick, folks. This angle is 40 degrees. That's not going to help me find an angle in the triangle. This is 350, this is 40. Now what I need to do is I need to find another angle or another side. Well, the easiest way to do that, if I want to use oblique trigonometry, is to find this angle here. Okay? That seems difficult. There's another way to do it. We can break the airplane speed and the wind speed into vectors and add them together. So we're going to do that. And I'm going to remind you of a few equations. The x component of any vector is the vector times the cosine of its angle. And the y component of any vector is the vector times the sine of its angle. So I'm going to make me a little table here, 350, 40, and my total. I have an x component and I have a y component. Now, to find the 350 degrees, if we look at this, this is going northeast. Northeast is in quadrant 1. So the x and the y components should both be positive. If I look at my wind is coming from the southeast, which means it's blowing towards the northwest. Northwest is a quadrant 2 angle. And in quadrant 2, x is negative and y is positive. Okay? Now, given that information, we can find our x and our y components. To find this component, we're going to say 350 times the cosine of... Now, here's the problem. This angle is measured from the north axis. It's 40 degrees. We can't use that. We have to find the angle from the horizontal, and that angle from the horizontal is going to be 50 degrees. Okay? It's going to be 50 degrees. Now, why is that? Well, because north and east make a 90-degree angle. So if you're 40 from north, you have to be 50 from east. Okay? So this will be 350 cosine of 50. And 350 cosine of 50 will give me 225.0 if I go for significant figures. And this here will be 350 sine of 50, and that gives me 268.1 if I go to 4 significant figures. Now, what about this wind vector here? Well, it's 20 degrees from a vertical axis, right? It's 20 degrees from the north axis, or it's 20 degrees from the south axis. Well, if I've got an angle, let's just say, here's north, and I've got a vector that's 20 degrees from the north axis, and it's going northwest. Here's west, okay? If this is 20, north and west meet at a 90-degree angle, and since this is 20, this has to be 70 because they're complementary angles. And so the angle we're going to use with this 40 is 70 degrees because it's measured from the x-axis. So we're going to type this into our calculator as 40 cosine of 70. And this we're going to type in as 40 sine of 70. And when we do that, we're going to get 13.68 and 37.59. Now, we've broken our vectors into components. All we have to do is add them up. So when I add 225 and negative 13.68, I get 211.3. And I'm going to keep this to 4 significant figures. And when I have 268.1 and I add 37.59 to that, I'm going to come up with 305.7. 4 significant figures. So the components of our resultant are here. But we don't want the components. We want the magnitude, which is the speed, and the bearing, which is the direction angle. So the magnitude is real simple. How do you find the magnitude of any vector? You square the components and take the square root. So 211.3 squared plus 305.7 squared, and then take the square root, and you get 371.6. This is the magnitude of the resultant, which will be in miles per hour. Okay? Now, that answers half of the question. What is the speed of the plane? Now, next issue is this. What is the direction angle or the bearing of the plane? Well, to find the angle of the resultant, it's going to be the inverse tangent of the y component, 305.7, divided by the x component, 211.3. And if I take the inverse tangent of 305.7 divided by 211.3, I get 55.35 degrees. Now remember, this is a mathematics answer. It's based on the positive x-axis. Bearing is measured from the north or the south. So, I want to convert this into a bearing. Well, the positive x-axis is east. So this would be like, say, starting at east and going 55.35 towards the north. Okay? Well, north and east meet at a 90-degree angle. So I'm going to ask you the question, what is 90 minus 55.35? And the answer to that is it's 34.65 degrees. 34.65 degrees. So what is the bearing of the plane? This is if you go from the x-axis towards the y-axis. This is if you go from the y-axis towards the x-axis. Well, that's how bearing's measured. So our answer would be north 34.65 degrees east. Now, why is it north and east? Ask yourself this question. What quadrant is 55 degrees in? It's in quadrant 1. So in quadrant 1, what direction would that be on a compass? It would be northeast. And that's how you pick, is it northeast, northwest, southeast, or southwest, based on which quadrant your answer is in. If you have any questions, please come see me.